Something is pulling our galaxy. The Milky Way, along with every galaxy within hundreds of millions of light years of us, is being dragged at 1.3 million miles per hour toward a single region of the sky. Not drifting, not expanding outward with the rest of the universe. Being dragged in one direction by something massive enough to move everything in our corner of the cosmos at once. And for decades, when astronomers pointed their telescopes toward that region, they saw almost nothing. Not because nothing was there, because we couldn't see it. The Milky Way is a flat disk of stars, gas, and dust. We live inside it. And when we try to look outward through the thickest part of that disk, the plane of our own galaxy blocks the view. Dust absorbs visible light. Dense star fields drown out faint signals. Across a band that stretches roughly 20% of the entire extragalactic sky, the universe behind our galaxy is effectively hidden. Astronomers call this region the Zone of Avoidance, not because the universe avoids it, because we have no choice but to avoid looking through it. The galaxies are there. The structures are there. We simply cannot see them at optical wavelengths. And the direction we are being pulled toward sits right behind that curtain. So here is the situation. We are being pulled fast in a specific direction. And the part of the sky in that direction was, for most of modern astronomy, a blind spot. That is how the mystery began. In the late 1980s, a team of 7 astrophysicists found a way to measure how galaxies were moving across the sky. Not just how fast they were receding, but how they deviated from the expected expansion of the universe. What they found was a pattern. Hundreds of galaxies spread across an enormous volume of space, all drifting in the same general direction. Not randomly, coherently. Like water moving toward a drain that no one had mapped yet. They called the unseen source of this pull the Great Attractor. It seemed to be located roughly 150 to 250 million light-years away, hidden behind the Zone of Avoidance. And based on the strength of the flow, it had to be massive. Early estimates put it at something like 10 quadrillion solar masses. An almost incomprehensible gravitational concentration sitting just out of sight, pulling everything toward it. For a while, the case seemed closed. The anomaly had a name and a location. The Great Attractor was the answer. Then the answer started to fall apart. New instruments changed what we could see. Radio telescopes, operating at wavelengths that pass through galactic dust as if it isn't there, began mapping the hidden sky. X-ray observatories detected galaxy clusters radiating high-energy light through the Zone of Avoidance. Infrared surveys picked up thermal signatures that optical telescopes had missed entirely. The curtain did not disappear, but it became thinner, and what astronomers found behind it was not what they expected. The Great Attractor was real. There was a genuine concentration of mass in that region, anchored by a large galaxy cluster called the Norma Cluster. But its mass had been overestimated by roughly a factor of 10. The gravitational pull it could actually exert was far too weak to explain the motion of the local group. And more importantly, the flow did not stop there. Galaxies near the Great Attractor were not converging on it. They were moving through it, still drifting, still accelerating, toward something further away. The Great Attractor was not the source. It was just caught in the same current. What lay beyond it was the Shapley Supercluster, roughly 650 million light-years away. One of the most massive concentrations of matter within 1 billion light-years of Earth. More than 8,000 galaxies packed into a volume roughly 200 million light-years across. When astronomers extended the velocity maps past the Great Attractor, the flow lines converged there. Not on a nearby anomaly half hidden by dust, but on a structure so large and so far away that it had been overlooked for decades because its gravitational influence was spread across an enormous volume of space. This is where the map changed shape. The region of space in which galaxies share this coherent inward flow, all draining in the same general direction, was formally defined in 2014 as a supercluster. It was named Laniakea, a Hawaiian word meaning immense heaven. It is not a gravitationally bound object. It is a watershed, a volume of space defined by the fact that everything inside it is moving the same way, toward the same basin. And the basin is not the Great Attractor. The basin is Shapley. But even Shapley was not enough. When researchers modeled the expected velocity of the local group using only the gravitational pull of known structures ahead of us, the numbers did not add up. The attraction from Shapley and its surrounding concentrations could account for part of our speed. Not all of it. Something else was contributing. And in 2017, a team of physicists published a result that changed the geometry of the problem entirely. They found that on the opposite side of the sky from Shapley, roughly 720 million light-years away, there is a vast region of space that is almost empty. Not a wall of matter, not a hidden cluster, a void. A region so underdense that it creates, in effect, a relative push. In general relativity, a region with significantly less mass than its surroundings does not pull matter inward. The denser regions around it do, which means matter flows away from the void, outward, toward where the mass is concentrated. The researchers called it the Dipole Repeller. It is not a force in the traditional sense. It is an absence that functions like a force. A hollow in the gravitational landscape that tilts the floor away from itself. The picture that emerged was this. We are not simply being pulled forward. We are caught between two immense influences. Ahead, the Shapley Supercluster, the densest known structure within reach, pulling everything toward it. Behind, the Dipole Repeller, a vast emptiness with nothing to hold us back, letting us slide further and faster away from it. Pull from the front, push from behind. And the local group, our galaxy included, sits almost exactly on the line between them. That is the closest thing to an answer that current data can offer. Not a single hidden mass dragging us through the dark. A gravitational dipole. A universe shaped not only by where matter gathered, but by where it didn't. We will never get there. The structures pulling us forward are real. The motion is real. But the universe is expanding, and that expansion is accelerating. Dark energy, the force driving space itself apart, is working against every gravitational bond that is not already tightly held. The Laniakea watershed is not permanent. Over billions of years, the galaxies inside it will drift apart. The flow toward Shapley will weaken. The coherent current that defines our supercluster will dissolve. We will not crash into the Shapley Supercluster. We will not even remain part of the same large-scale structure. The path we are on leads nowhere that we will ever reach. We are moving at 1.3 million miles per hour toward a destination that the universe will take apart before we arrive. The mystery was never really about what is pulling us. It was about what kind of universe we live in. One where the structures are real, the forces are measurable, the motion is constant, and the destination does not exist.